Hello and welcome to Maths with Jacob. This lesson will focus on problem solving part 2. This video is a continuation of the previous lesson where we present more examples on problem solving. Example 1, 3 numbers add up to 9. If one number is 3 and the second number is 4, what is the third number? So for the solution, we know the first number is 3, the next one is 4, and we have to find the third one. And it says they add up to 9, so that's the plus sign. So 3 plus 4 is 7, so 7 plus the third number add up to 9. If we count on from 7 to get to 9, that gives us 2 places. So in other words, the star must equal 2. For the previous problem, the students could use any concrete materials like marbles or matches, for example, to help them. Also, they may choose to use a number line. Example 2. 3 consecutive counting numbers add up to 12. What are the numbers? Now please spend a little bit of time explaining to students what the word consecutive means, so they know what type of numbers we're using. They are obviously counting numbers, and just remind them what they are, but they need to understand what the word consecutive means. So for the solution, students may use trial and error in the first instance. They may, of course, use any strategy. So for the trial and error, if we take the first 3 counting numbers, 1 plus 2 plus 3, that gives us 6. So that's not correct because we need an answer of 12. If we then have 2, 3 and 4, 2 plus 3 plus 4 gives us 9. That's not correct because we need an answer of 12. If we try 3, 4, 5, 3 plus 4 plus 5, add those together, and that gives us 12, and that is correct. Example 3. What are the total number of sides for a square, a rectangle, and a triangle? Now impress upon students that a very good way to start here is by drawing each of these two-dimensional shapes. So the square has 4 sides, the rectangle has 4 sides, and the triangle has 3 sides. 4 plus 4 plus 3 gives us 11 sides altogether. So the word total, that's what that means. You have to add those up. 3 people are in a race. How many different ways can they finish in the race? So spend a bit of time with this. It's a very interesting little problem. So if you have 3 people running, just draw them. Or you could use concrete objects on a desk if you like, different colours. Here I've just used the people. So if this young chap here comes first, those two come second and third. We'll keep this young chap at first and swap those two around. Then the yellow one could win, and then we have second and third. If the yellow one still wins, we swap those two around. And lastly, this gentleman can win. We have second and third. Keep the same gentleman as the winner and swap those two around. In other words, when we look at all these different things here, these different finishing order, the different places, there are 6 different ways. First, second, third. First, second, third. Can you see? 1, 2, 3, 4, 5, 6. There are 6 different ways they can finish. Example 5. 20 horses need to be transported in 4 trucks. If there are the same number of horses in each truck, how many horses are in each truck? So the important thing is there are 20 horses. Now here are the trucks, 1, 2, 3, 4. So students can draw the trucks, or they can put something on their desk or on the floor to represent a truck. Now it says that the same number of horses. So this is the importance of reading. You must read the problem carefully and understand what it's telling us. So if we look at this truck here, let's say we have 1, 1, 1, and 1. So here we have 1 horse in each truck. That's only a total of 4. Remember, we have to have a total of 20. So we put another 1 in each truck. So this, say we load them up one at a time. Now we have 2 in each truck for a total of 8. Then we put 3 in each truck. That gives us a total of 12. Then we put 4 in each truck. That gives us a total of 16. So we still haven't got 20. We put another horse in each truck. And look what we have. 5, 10, 15, 20. So we have a total of 20 horses. And there are 5 in each truck. So that's a good way of doing it logically. Just take your time and the answer comes out naturally. Example 6. Bill is 4 years old. Sue is 2 years older than Bill. Tom is 3 years older than Sue. What is the sum of their ages? So again, the students could use concrete materials here. They could put 3 things on the floor or on their desk, one representing Bill, one representing Sue, and the other representing Tom. They can put 4 objects near Bill. I've just written the number 4. Near Sue, it says Sue is 2 years older than Bill. So we take Bill's age and we add another 2 objects. So altogether that's 6 objects. In other words, Sue is 6 years old. And then it says Tom is 3 years older than Sue. So if Sue was 6, we add another 3 objects there. 6 plus 3 is 9. So the sum of their ages, so we found that Bill is 4, Sue is 6, and Tom is 9. Sum means addition. So 4 plus 6 plus 9 is 19 years. So the sum of the 3 ages is 19 years. So this has been another video to give students examples of problem solving and how to go about it. And please impress upon them the importance of reading the problem, even if you have to read it 2 or 3 times, to understand exactly what's required.